An eclipse is a celestial event that occurs when the sun, moon, and earth are lined up. During a solar eclipse, the moon is aligned between the sun and the earth, and its shadow can partially or fully block the light of the sun. A solar eclipse can occur at least 2 times a year somewhere on Earth. During a lunar eclipse, the Earth is aligned between the sun and the moon. Earth's shadow can dim the light of the moon and sometimes turn the surface of the moon red. For this activity, you will create a total solar eclipse. You will need a circular object, pencil, chalk, tape, and black construction paper. First, let's draw the sun. Trace your circular object with chalk. Color and use your finger to fade the chalk towards the outer edge of the paper. Next, you will create the moon. A solar eclipse happens at the new moon phase, when the moon's surface is not visible from Earth. Trace your circular object on the black paper and cut. Tape the circle to a pencil or craft stick. Ready for a creativity tip? Let's simulate a total solar eclipse. As the moon travels in the sky, it aligns with the sun and blocks the light, only revealing the corona, which is the sun's outermost atmosphere. The sky is temporarily darkened, but will lighten up as the moon continues its orbit.
If we think about the beautiful moon of Europa hanging out there in the sky, it's one of the moons of Jupiter, and we can imagine almost anything because we don't know. And maybe if we do the drawing, we think it's just not enough to have a feeling of something which is so big and so made of different structures. So we can decide to make it as a collage, and we can take the color paper and basically draw the shape of what we think Europa might look like, which would be like what we see in the sky, and it's a round moon. And so we cut it with the scissors. So this is my sort of cut Europa, and then I decide maybe to show the body of water we're looking for. So I would decide to have lakes. So I will make 2 lakes here. I have 2 lakes. And if I decide to take a piece of red, make it into the mountain. It can become almost like a little duckling or something, but it depends how, again, you use your imagination. And you can put in also little yellow spots, which would be other rocks and other mountains, or you can put in the green clouds going over Europa in the space. So when we look from planet Earth, we see this beautiful, beautiful picture. And in the end, when we're happy how it all looks, we take the glue, we use some paper we disregard, and we can glue all these things together. Everybody should do it in their own way, in their own colors, in their own shapes. And sometimes you can glue in even pieces of cloth or pieces of trees. I mean, collages are open to anything, and this was just to show you how it can be done.
One One of my favorite wonders in the universe is a nebula. This colorful giant cloud of dust and gas can sometimes occur because of the explosion of a decaying star. They also contain regions of new stars, sometimes called star nurseries. The world's most powerful telescope, the James Webb Space Telescope, will soon be starting its science mission and sharing its first images with the world. Nebulas are just one of the many things it will see in the colorful cosmos. Today, you will be creating a colorful nebula. For this activity, you will need paint, markers, and black paper. Nebulas are very colorful because of the gases that are present. First, decide what color you would like to use in your work of art. Using your paintbrush, begin adding blots of paint on one side of your paper. Clean and dry your brush between each color. Ready for a creativity tip? Fold your paper in half to cover the paint. Gently rub your hand across the paper. Peel back the paper to reveal the colorful explosion. After the paint is dry to the touch, use the markers to add stars inside and outside the nebula. How will you show your colorful nebula to family and friends? Circles, circumference, and pi, oh my. Math is all around us, and it comes in different shapes and sizes. Pi is one of the most recognized mathematical symbols that calculates the ratio of a circle's circumference to its diameter. The circumference is the distance around the circle. The diameter is the distance across the circle. The circumference is usually a little more than 3 times the length of the diameter. This ratio is approximately 3.14159, and it's the same for any circle no matter the size. There is even a Pi Day that's celebrated on March the 14th because the first 3 digits of pi are 314. For this activity, let's explore creating a circle using straight lines. You will need paper, markers, and a protractor. Let's begin by creating an implied circle using dots. Place the protractor on the center of the paper. Mark a dot every 10 degrees beginning at 0. Turn the protractor to the opposite side and repeat. Ready for a creativity tip? Identify 3 dots of equal distance on the implied circle. Mark those dots slightly larger than the others. Using the straight edge of your protractor, begin connecting dots of equal distance going counterclockwise. Notice as you connect the dots, a parabolic curve forms in the center.
We ask questions about many topics that interest us. But not all questions are equal. In this activity, you and a group of friends will select a STEAM topic that is often in the news. For example, forest fires and landslides. Your STEAM team will learn more about this problem by creating an inquiry ladder of important questions. You will need poster markers, erasable colored pencils, poster board or a long roll of paper, sticky notes or small pieces of paper, tape, connect. We often see natural disasters like forest fires and landslides in the news. What questions would scientists, technology experts, engineers, artists, and mathematicians ask themselves to tackle those problems? How do STEAM teams use inquiry to learn more and imagine new solutions? Create. First, create an inquiry ladder, which is a design that helps organize questions into different types. The lowest ladder rung is where you will put the rule-setting questions. The next section, moving up, is for fact-finding questions. Then move up to clarifying questions. And finally, put your essential questions on the top. These are the highest level of inquiry. Present. Now write your questions on sticky notes or small pieces of paper and attach them to sections on the ladder based on type. As your team comes up with more questions, figure out where on the ladder they fit. Would "how much time do we have for this" be a rule-setting question? Is "do we need an equal number of questions in each rung" a clarifying question? An essential question might be, how can people prepare for natural disasters? Respond. Asking questions is a great way to respond to STEAM problems and find new solutions. Think about what else you want to know and how you can find out. Turn curiosity into inquiry. When we ask essential questions, we think like a STEAM team.
Let's create a spaceship. The basic structure of a space shuttle is made up of the orbiter, rocket boosters, and external fuel tank. Let's start with creating the orbiter. It is shaped like an airplane. Take a piece of Model Magic and roll into a cylinder shape. This is the cargo bay and flight deck. Roll and flatten a piece of Model Magic to mold into the shape of the wings and rudder. Attach to the cargo bay and flight deck. Let's make the external fuel tank and 2 rocket boosters. Roll each into a cylinder shape that vary in size. The rocket boosters provide the shuttle with millions of pounds of thrust to overcome the Earth's gravitational pull. Ready for a creativity tip? Illustrate surface details such as panel lines, bolts, and logos.
In this activity, you and a group of friends will create and play a card game that pairs natural solutions with real-world problems. You will need erasable colored pencils, crayons, markers, index cards or cardstock in 2 different colors, scissors. Create! Today, you will design an innovation card game inspired by nature. Start by creating at least 2 dozen color-coded cards. On one set of cards, sketch symbols and words that show 1 real-world problem per card. On the other set of cards, sketch or write possible solutions that come from plants, animals, and the environment. Next, label the back of the cards by type, either problem opportunity or natural inspiration. Now, turn them sketched side down and randomly pull a card from each set to form unlikely pairs. Connect! To play the game, team members help each other figure out ways to connect a card from each set to describe a STEAM problem and possible solution. You can trade cards with other players and research topics to learn more about natural solutions. Imitating nature is a great way to solve problems. How could studying bees help humans build stronger structures? How do desert creatures store water, and could people use this to solve water shortages during droughts? Present! Present your ideas to other STEAM teams or family members. Respond! Respond to others' ideas with enthusiasm and additional suggestions. Sketch ideas to help others see what you are thinking. Nature is an outstanding problem solver. To create everything imaginable, STEAM teams observe and imitate nature's elegant solutions.
Art and math might seem like distant worlds, but they are strongly connected. For example, they share the same vocabulary, like patterns, shapes, and lines. When art and math skills are combined, you can create a tessellation, which consists of repeated shapes that cover a surface without gaps or overlapping. What are some examples of tessellations that you can think of? For this activity, you will create a translation tessellation. You will need index cards, pencil, paper, tape, scissors, and markers. First, you will need to make your index card a square by placing the two cards perpendicular where the top and sides are aligned. Draw a line and cut. Next, decide where you will draw your design. I'm choosing the top and left side of the card. Draw a very simple line design along the edge of the card to make a shape. Cut out each shape. Move and tape each shape to the opposite side of the card. Ready for a creativity tip? Align your card to the top of the paper and trace the outline. To make this a translating tessellation, slide the shape, align, and trace. Repeat this process until you fill the page. Remember, there are no gaps or overlapping. Complete your design by adding colors, lines, and shapes.
Look, a for sale sign on the orchard.
I wonder who is interested in this land and how they plan to use it.
Let's imagine how different plans might come to life by creating art that shows what this area could look like in the future. You will need sketch paper to draw drafts, poster board or large paper, erasable colored pencils, oil pastels, poster markers, colors of the world markers.
Respond.
The realtor said there are 3 possible purchasers already interested in buying the orchard. An entrepreneur who wants to keep growing fruit and plans to add a pie and jam shop.
A building company that wants to create an eco-friendly housing complex. And the city, who responded to citizens' petitions requesting that the land be turned into a nature preserve.
Create. I'm drawing the new store based on the entrepreneur's plans to add a roadside shop in the orchard.
I'm drawing a blueprint of the housing project using math and design skills to show where roads, electric lines, and water pipes will be located.
Let's work together on ideas for the new nature preserve. I'm super excited about this option.
Present.
Showing our art at the City Council land use meeting might help decision makers see what this land could look like in the future.
Many citizens have come to the meeting to voice their points of view. Changing land use from farming to housing requires City Council approval.
Connect. Hearing the comments at the City Council meeting gave me new ideas for how the land could be used. I like the university's idea of teaching agriculture classes on experimental farming there.
I got inspired to visualize it as a community park with play equipment that could be accessible to everyone.
No one knows what changes the future will bring. When we picture possibilities, it helps us become future ready.
STEAM teams wear many hats. When teams explore STEAM problems, they ask questions wearing the hats of scientists, technology experts, engineers, artists, and mathematicians. Each field provides a special way of looking at a problem, and each requires creative thinking. In this activity, your team will explore the Boston molasses flood of 1919. Then ask STEAM questions to figure out what went wrong. You will need crayons, markers, metallic colored pencils, drawing paper, scissors, tape. Create. Start by drawing 5 large hard hats, attaching each to a headband that fits your head. Label each hat with one name: scientist, technological expert, engineer, artist, or mathematician. When you wear each hat, you will think about questions from that point of view. Respond! The Boston molasses flood story is fascinating. On January 15, 1919, a 7.5 million liter wall of molasses burst from its distilling company's storage tank and tore through Boston's north end. The flood created a 40-foot tsunami-like wave that caused damage and death. Research more about this disaster. Then respond by thinking of questions from the point of view of each hat, one STEAM perspective at a time. Present. Present the questions your team thought of, organized by each STEAM profession. Scientists might ask, what was molasses used for in 1919? Did weather contribute to its fermentation and the tank bursting? Tech experts ask, how could monitors have warned people? Engineers might ask, what structural problems were there in the storage tank? Artists ask, what visual clues on the tank showed color and texture changes as early signs of leaking? And mathematicians might ask, how did the molasses travel so fast and so far? These are just some questions. Your team can come up with more. Connect! Connecting insights from all 5 fields helps to solve the mystery and prevent similar problems in the future. For example, they learned that the tank had been repainted to hide the leak stains. The disaster could have been avoided if early visual clues had been explored and understood. STEAM team collaboration helps us see problems from new perspectives.